go. If you're mad about something, just let me know, okay?
Nothing to do, nothing. So, throw these guys out of here.
Tell him to stop sitting next to me.
He didn't even have a slide.
Yeah, don't make me separate you guys, okay? All right, the class before spring break. Everybody is always happy to be here for this particular class. I realize that, okay? I can see the excitement on your faces. I'm just hoping none of you jump out the window tonight, okay? You look kind of desperate. Okay, so we've got tonight. Next week you have off, so be sure to relax, have fun. If you're going out of town, be safe. Take lots of pictures. Let me see them. I mean, you know, spring break pictures are all exciting and fun to see. I'm just kidding, by the way. And if you're staying here, working or whatever it is, then well, you'll be like me. So you'll just be here in Murray. But what I'm going to do tonight, I thought we should really, you know, send you off to spring break with a fantastic topic. So we're going to talk about asset liability management tonight. Okay? So you need to all just stay in your chairs. Don't jump up and cheer. We need to keep this orderly. Okay? Now, this is probably one of the more, how should I put this, confusing topics that we'll cover, at least initially. Because I think for most of you, once we go over it, you've had a chance to get through spring break and then get back here and kind of get back into a study mode, I think it will make more sense to you. Okay? But so we've got chapter 7, and we'll run through that. Now, I did want to point out that last week we talked about the research paper. So the librarian who was here, she sent me this, okay, under research paper information. So this is what she passed out in class, for those of you who weren't here. And then there is also a Tegrity recording of what I discussed in the second part of class, and so you can find that here, okay, for the paper research, how to find a UVP, RFD1, etc. So all of that is there. So again, I know that it's some of you have talked to me about your paper topics. You've been doing a really good job of coming up with some topics. And it's still a long way off, okay? But if you want to get started, let me know. Contact me about topics if you have a question about it. If not, then just go ahead and jump right into it and start working. But what I found is with most papers, just like this one, the toughest thing is just getting started. Once you get started, you just get it knocked out. But just coming up with a topic and getting started is typically the most difficult part. All right, so are there any questions about anything related to what we've done to this point before we jump into chapter 7? And I will tell you that not all of it, but a lot of what we're talking about tonight, this is the exact same presentation that I make to bank schools whenever I'm teaching this topic. Okay? Now, we're covering about half of it, but still, it's the same stuff. So if you kind of understand what's happening with asset liability management here, then if you decide to go work for a bank, you're going to be way ahead of a lot of other people. Okay, so I wish I had a clicker, but I don't, so we'll make this work. All right, so the definition of asset liability management. This is the official definition. I'll give you a simpler one in just a minute. It is controlling a bank's sensitivity to changes in market interest rates and limiting losses in its net income and or stockholders' equity or owner's equity. So what that means in simple terms is interest rates change. Interest rates go up, interest rates go down. Right now, what environment are we in? A rising rate environment or a falling rate environment? Are interest rates going up or down? They're going up, okay? Everybody knows they're going up. Now, the thing here is what we're trying to do with this is we're trying to control what happens to a bank's income and or the value of its capital, because think about everything in a bank that is associated with interest rates. Deposit accounts, loans, investments, and those are all changing. They're going up or down depending on what's happening, and they're changing by different amounts. So basically, we're trying to keep all of this under control when it comes to all of these different accounts. So it sounds kind of simple when you just read the definition, but in reality, it's a lot more difficult because we can't just shut everything down at the bank. For example, if rates go up, you can't just stop everything like you can with some experiments and say, okay, today we're not making any loans. Today we're not accepting any deposits. Today we're not paying any checks. We're going to have a control environment, and then we can see what's going to happen once we start up with our activity. Okay, so it's not like growing one plant with fertilizer and one plant with no fertilizer. Okay, we don't have that test subject that we can use because everything is constantly moving. So as we take a look and as we move through asset liability management, you've got some different views of this, and this is kind of just a quick history lesson of what's happened in the banking industry. But early, when banks were trying to control this, basically, it's called asset management strategy. They thought that the amount and type of deposits were basically out of control of management. So this was determined by the public. Whatever the public wanted in terms of deposit accounts, whether it was savings, checking, CDs, whatever, that's what they had to provide. And so they didn't really pay much attention to the liability side because they felt that was out of their control. They just paid attention to the asset side, which was loans and or investments. And so that's what they tried to manage. Then as time went on, now again, keep in mind, this is going through a lot of different regulation through the years. They kind of jumped over to what's called liability management strategy. And with this, what it's saying is that prices, this is interest rates, determine the cost and mix of funds flowing in or out of the bank. And if there is a heavy demand, and this is a heavy loan demand, then it's pretty simple. If there's a lot of loan demand, a bank can increase the price that it pays on its deposits, and money is going to flow into the bank. A lot of this is really common sense. Now again, think of this from you're the person running this bank. And if there's very few loan possibilities or investment possibilities, then they're going to leave deposit rates unchanged or actually decrease rates because really the bank doesn't want deposits if it doesn't have anything to do with those deposits. And we've seen that over the last several years. As a matter of fact, about the last 12 months, you've seen deposits actually start becoming more valuable to banks because for the last 10 years, banks were having to, a lot of times, pay deposit rates. Sometimes they didn't even want the money. I mean, I've had banks in this classroom, or bankers in this classroom, talking to my Finance 537 class saying, we'll have customers bring us money, and a lot of times we don't want that money. But we think we have to take it because we've got a relationship with that customer, but we really don't have anything profitable to do with the money that they're depositing in our bank. So this went on for a while, kind of dealing with the asset side. And then that kind of brings us around to what we're going to be studying in this chapter, which is called funds management, or basically just controlling both the assets and the liabilities. So that's what we're going to be looking at. And again, keep in mind that both of these are changing. So we're trying to determine what's going to happen to the bank's profitability, what's going to happen to the bank's capital, because you don't want to guess at this. You don't want to just set a deposit rate. Okay, so we're going to pay 1% on our savings accounts. We're going to charge 10% on our car loans. We're going to charge 12% on unsecured personal loans. And we're going to charge 6% for real estate loans. You don't want to just set this arbitrarily and kind of hope for the best as the year progresses. So we've got, and every bank has this, what's called an Asset Liability Management Committee. And this Asset Liability Management Committee, they are, or you'll hear me refer to it as simply the ALCO, they are taking a close look at what's happening with the bank's deposits and assets, typically once per week, sometimes more often than that. They will meet. They're going to have representatives from all parts of the bank. So, for example, you're going to have a loan officer. You're going to have a person from investments. You're going to have a person from deposit. Now, when you see the word funding, this is actually referring to deposits. And they're going to take a look at, how much risk exposure do we have? What do we want to happen with our deposit rates? Because, and again, right now, there are some banks that are in really good position, and we'll talk in a few minutes about, in a rising rate environment, how do you want to be situated as a bank? Do you want assets repricing? Do you want liabilities repricing? Which one do you want faster, and which one do you want more of? Because that's going to make a big difference in terms of the profitability of the bank. Also, the board of directors has to get involved. Now, again, for years, board members, a lot of times they didn't know much about banking. Today, most of them do. They have to. When I was at the meeting at the Federal Reserve Bank in Atlanta a couple weeks ago, 3 weeks ago, they had a special session on board members, and it was talking about how banks today, previously, historically, bank board members were people who owned a lot of stock in the bank, and most of them knew nothing about banking. So they were doctors, attorneys, pharmacists, big farmers, dentists, other business people. They owned a lot of stock. They did whatever they did for a living really well, but they didn't know much about banks. And that was fine. That worked fine because as a bank president, man, I'd love to have those kind of people. Because guess what? They don't question what you think. You go to the board meeting, you put up a bunch of slides, you show them what the bank is doing. They sit there and look at it. They ask what the bank is doing. Say, yes, it's doing well, and that's it. That's all you had to do. Today, that's different for a couple of reasons. One is the 2008 financial crisis. We had a lot of change in laws, so now board members, there's a ton of personal liability to being a bank board member. When you become a board member, not only is the bank in your hands, but also a lot of your personal assets can be at risk because if you don't read the reports, if you don't understand what you're signing off on, you can lose a lot of money. Okay, they can go after you personally in what's called civil money penalties and or jail time. So that was a big factor. So for a few years there, 5 or 6 years after the crisis, banks had trouble recruiting board members because most people said, it's just not worth it, okay? Now that's changed over about the last 4 years, I guess. But what banks are doing now is they are paying, first of all, they're paying better for board members, but they're paying for talent, specific talent to sit on their board. For example, if you're an information systems expert, there's probably a bank out there that would like you on their board of directors. Now, why would you think an information systems expert would be helpful as a board member of a bank? Was what? Okay, because they have a lot of systems, but what's been happening? What do you see in the news a lot? Cybersecurity. That's right. If somebody hacks into your system, if you've got an expert on your board, you can react quickly. You'll react quickly anyway. You'll call your consultant or whoever, and they'll start working on it as soon as they can. But if you can pick up the phone, call your board member, they can start, immediate action, whereas your consultant, it may take them a day or two to get there where there's, kind of look through things. And banks are willing to pay for this expertise. So whether it's an accounting expert, I actually had a bank at my advisory board meeting, after we were talking about this, I had a bank president come up to me after the meeting, and he said, look, we're looking for 2 people to sit on our board. We're looking for an accounting expert, and we're looking for an information systems expert. And we're willing to pay for those people, pay really well, for those people to sit on our board? Do you know of anybody? So, I mean, this is happening. This is changing. And this is a big difference because if you'd been in banking and seen sort of what a lot of bankers had to deal with over the years, it's actually pretty impressive now that you've got people who actually know what's happening within the bank. Plus, it makes the bank's officers, you have to be sharper. You have to be more accountable because those board members are going to question what you're presenting to them. They're just not going to take it at face value and say, okay, yeah, Lacewell, I'm sure you're doing a good job. Now they want to know that you're doing a good job. And again, this kind of goes hand in hand with what we talked about. Senior management is responsible for ensuring that board-approved risk strategies, policies, and procedures are appropriately executed. What this means is that whatever the bank does, they have to have in writing in terms of a policy that, yes, we can do this. It's allowed by the board. It's allowed by the bank's policies. Or, no, we're not going to take certain risks. When an examiner comes in, they're going to look at your policies, they're going to look at what you're doing, and they're going to make sure what you're doing matches up with your policies. If it doesn't, you need to either change what you're doing, you need to change your policies, or both, because they're not going to be extremely happy with what you're doing. All right, now we've got the CAMELS rating. I think I touched on this probably back in chapter 1 or 2. But this is something you need to be familiar with, okay? As a former bank examiner, I think this is just a really important part of any banking class. So there's something called the CAMELS rating, C-A-M-E-L-S. And so I'm going to go through each one of these. The C in the CAMELS rating, this is what when regulators come in, they rate your bank on, let me just go ahead and bring them all up here. They rate your bank on these 6 areas in terms of the safety and soundness. And then once they rate these areas, they're going to rate your overall composite in terms of, it's not really an average. A lot of people think, well, they just take whatever these receive and average them. That's not exactly how it works. But these are rated on a scale of 1 to 5. 1 being the best, 5 being the worst. So they're going to look at C, your capital adequacy. What do your capital ratios look like? Is your capital increasing? Is it decreasing? They're going to look at the asset quality. This is primarily loan quality. What kind of loans are you making? Although they're also going to look at your investments, see what kind of investments you're making. Management quality. This is a little difficult to quantify, but they're going to look at the history of management. Are you changing out bank presidents every other year because you can't keep anybody? What's happening, what kind of job is management doing? They're going to look at your earnings or your profitability. And not just this year, they're going to look at the history of your earnings. So what have you done over the last 5 years? Have earnings been increasing? Have they been decreasing? They're going to look at your liquidity. And finally, they're going to look at your sensitivity to market risk, or another way of saying this is sensitivity to interest rate changes. And that is what we are going to be focusing on in this particular chapter, is the S portion of the CAMELS rating. Now, this kind of shows you that this hasn't always been the CAMELS rating. Up until 1996-97, it was the CAMEL rating. So when I was a bank examiner, we just had 5 of these to deal with. And then they added the S portion because you were seeing a lot of banks go out of business because they weren't basically watching their asset and their liability management, and before they knew it, interest rates were increasing or decreasing, and they were insolvent. The next step is your doors are closed. You're selling your bank to somebody else. Now, interest rate risk consists of various items. Some of these weighted more heavily than the other, depending on the bank, depending on the bank's circumstances, depending on competition. One of them is, and I'll go through an example of each one of these in just a minute, but the first is repricing risk. Repricing risk is just what the name implies. It's the possibility that assets and liabilities will reprice at different times and negatively affect an institution's earnings, capital, or general financial condition. So that's simply interest rates changing. The second one is options risk. This is the risk from options in a bank's assets and liabilities. Now, a lot of times when people think about options, they think about really complicated financial instruments. It doesn't have to be the case. For example, if you make a loan, that loan may have a prepayment option, which means that if you make a loan today at a low interest rate, or excuse me, let me back it up. If you make a loan at a higher interest rate, say a home loan, at 7%, and over the next year, rates go down to 5%, that customer may come in and refinance that loan. What that means is that 7% home loan rate that you were really proud of because you're making a lot of money on the interest now is cut to 5%. Or if you can't meet what the customer is demanding, you may lose that loan entirely. And so things like prepayment risk, call provisions, that type of thing on your investments, on your bonds, those are options that you have to be aware of because that can really change your income or your expense stream. Basis risk, and we'll look at an example of this. This is the risk that assets and liabilities reprice at different speeds and by different amounts. And that's what happens. When rates go up, banks tend to reprice their loans really fast, higher. But they tend to reprice their deposits up pretty slow. Only when they have to, typically only when competition makes them. When rates are going down, guess which accounts drop in terms of interest the fastest? Deposit accounts, okay? Because banks want to start paying those lower deposit rates. Loan rates tend to drop slower during falling rate environments. And so that's what this is referring to. Yield curve risk. Those of you who have taken or are taking ECO 305, how many people have taken that class, Money in Banking? Okay, so you probably talked about the yield curve, I'm assuming. You talked about that? Okay. Can anybody tell me what a yield curve is? A simple definition. Okay, keep all those answers to yourself, and when we bring up the yield curve in a minute, I'll come back to you on that, okay? This is the risk that unanticipated shifts in the yield curve have adverse effects on a bank's income and underlying economic value. So this is simply saying that the yield curve can shift in its shape and its steepness, and that can hurt the bank. And finally, price risk. The risk that the fair value of financial instruments will change when interest rates change. And this is something you learn in every finance class. If interest rates go up, what happens to the price of bonds? They go down. Okay, and banks are large owners of bonds. But also, because in every finance class, we tend to give that bond example. Interest rates go up, bond values go down. Interest rates go down, bond values go up. But also, it works the same way with loans. And we don't discuss that in most finance classes. But when interest rates go up, the value of a bank's loan portfolio goes down. When interest rates go down, the value goes up. We know that over the next few years, interest rates are going to be going up. So what's going to happen to the value of a bank's investments and loan portfolios? It's going to go down, okay? So a bank has to be ready for that. They have to be able to prepare for that to handle that increase in rates. All right, so these are, wow, that's really messed up. Let's go back. I don't have any idea what, yours doesn't look like this, does it? You should have some numbers on yours. Okay. All right, I don't know what's happening here, but I'll just kind of explain it to you if you've got it, if you're looking at it in front of you. This says that, and again, this is a really simple example, but let's say a bank funds a 4-year car loan, so you make a 48-month car loan, you charge 5% for that loan, and you fund that with 1-year certificates of deposit that the bank is paying 3% on. So what that's going to show is in 2016, you're making 5%, you're paying 3%, so you've got a difference here of 2%. Now, that's a pretty narrow profit margin, but I mean, you can still survive on that. But what happens if in 2017 interest rates increase? Now remember, you've locked this 4-year car loan in. It's a fixed rate. You're going to earn 5% on that loan for the next 4 years. But you've got a 1-year CD. So the next year when that CD matures, let's say that rates have increased on CDs to 4%. Well, now you're earning 5, you're paying 4, things are getting a little tight. And let's say in 2018, you're still earning 5%. Interest rates jumped up to now 6%. So you are now making a negative 1% profit margin. You don't necessarily have to be a bank expert to realize that if you're earning 5, you're paying 6, you're not going to stay in business long. And you may look at this and you think, wow, that is just so simple. I'm a college junior, I'm a college senior, I can see how that could happen, and I would know better than to ever do that if I were running a bank. Well, guess what? It's happened lots of times. You can go back to the savings and loan crisis of the 1980s, where you had savings and loans making primarily fixed rate home loan mortgages. So 10-year fixed, 15-year fixed, 20-year fixed, 30-year fixed rates. And they were financing those home mortgages with 3-month CDs, 6-month CDs, savings accounts, deposit accounts whose interest rates could change daily, monthly, quarterly, annually. And so you can imagine what happened, and that's basically what happened. You had interest rates going up quickly. These savings and loans had made a lot of fixed rate loans, so they were locked in. They had to start paying interest rates that were more than they were earning on their loan portfolio. You're not going to stay in business long doing that. So you had hundreds and hundreds of S&Ls failing, especially kind of along the Texas, Louisiana area, because it was a big oil production area, based on this. Something that all of you can see plainly, not a smart thing to do. But sometimes banks do things that aren't really smart, and we talked about this previously, but one of the main reasons is because your competition is doing it. And it goes back to probably what your parents told you, was that, you know, I can remember my parents saying that if you had a friend jump off a mountain, would you jump off a mountain with them? You know, that kind of thing. Well, it's the same thing what we're showing here. If your competition is doing it, your board says, hey, we've got to make more money. We need to get into that fixed rate mortgage loan arena. The problem is we're having to pay variable rate depositing rates, and that could shift on us like we're seeing here. Okay, options risk. We talked about this a little bit previously. But, I mean, there's lots of different options that can be embedded within financial instruments. For example, the option to refinance a loan. If interest rates go down, most people are going to come in and refinance their mortgage loan. It's simply a money saver for them. They're going to pay less interest. Some bonds can be called. They have call options. Depositors, they have the option to withdraw their funds prior to maturity. Just because you make a 5-year certificate of deposit doesn't mean that money's going to stay there for 5 years. A customer could come in after a year and say, yeah, I'm willing to take the interest rate penalty because I need my money. Now, by the way, some of you work at banks, or may have some experience with banks, what is an average interest rate penalty if somebody withdraws their CD early? So minimum $25? Okay. Okay. And it's kind of changed a little bit over time because it used to be interest that had accrued, but interest rates have been so low that really didn't amount to much. So now banks are charging, a lot of times they're charging just a dollar amount, a minimum dollar amount if you come in and take your CD out early. Now, let's make sure that you understand when I say CD, I'm talking about a certificate of deposit. So what that is, that's a deposit account where a customer comes to your bank, they're willing to give you their deposits, so maybe it's $1,000 or $10,000 or whatever, for a fixed period of time. So it could be, you could have a 3-month CD where they're giving you your money for 3 months. You can have a 1-year CD where they're giving you their money for a year. It goes typically up to 5 years. Now, most people at these really, really low interest rates aren't locking their money in right now for 5 years. And why would they? Because they think deposit rates are going to go up, and they want to take advantage and receive those higher deposit rates. If you lock it in now for 5 years, guess what? You're going to receive the same interest rate for the next 5 years. It's not going to change. And you can see some scenarios here that happen frequently. If interest rates go down, people pay off their old loans, they refinance their loans at lower interest rates. Investments can be called if interest rates fall, so you talk about this probably in your investments class. And then this says liability withdrawal typically occurs when interest rates rise. Now, somebody kind of explain, this is saying deposit withdrawal typically occurs when interest rates rise. Somebody explain that one to me. Because when you first look at that, it kind of goes against what you think might happen. If you think if interest rates are going up on deposit accounts, people are going to keep their money in the bank, or more of their money in the bank. But if deposit interest rates are going up, what other types of interest rates are going up on the other side of the balance sheet? Loans. Okay? Loans are getting pricier. So they're simply saying that, look, if a loan's going to cost me higher interest, I can take my money out of the bank, and instead of having to borrow at a higher interest rate, I can simply pay cash for whatever I'm buying. So this kind of works two ways. Another thing that I hear customers talking about quite often is if interest rates have been as low as they have been over the last few years, a lot of people will simply say, look, I might as well pay cash for whatever I'm buying because I'm not going to earn anything at the bank. The bankers in here heard that? Heard people say that? Yeah. So there's kind of a fine line to figure out the toughest thing, which is what customers do. That's tough because you think you've got them figured out. You think you've got your local market and your competition figured out, and then everything changes, and you have to start over. But this is what we call options risk. The next one is basis risk. This is simply saying that deposits and loan interest rates change at different speeds. Some go up fast, some go up slow. If you look at the second bullet point here, it says that rates, I can find my pointer, rates associated with assets, typically loans, tend to change faster in a rising rate environment and slower in a decreasing rate environment. That makes perfect sense. If I'm a bank and rates start going up, I'm going to start raising those loan rates as fast as I can because that's what provides me with interest income. If rates start going down, I'm going to be pretty stingy on taking those loan rates down. I'm going to wait as long as I can. But on the other hand, liabilities or deposits, they tend to change slower when rates go up. And you can watch this at your bank if you want to over the next year. You'll see loan rates as interest rates increase, which they're going to increase. You'll see loan rates going up pretty quick. You'll see deposit rates going up very slowly. That's just what happens. Okay? But if rates are coming down, those banks are going to start dropping deposit rates fast. And when customers ask about it, they'll say, well, look, rates are going down. We've got to drop our deposit rates. Nothing we can do about it. And it all has to do with interest income and interest expense. All right, so we've got a yield curve here. Let me build it. Oh, built too much of it. Okay, there we go. So, you can see here, for example, our blue line. Let's say that this was our original yield curve. And so what it shows is, and what you learned in money and banking, is that this is the interest rate on a 1-year maturity instrument of some type. This is the 10-year maturity. So the difference is called the yield curve spread. Well, what happens is, for example, if the yield curve gets flatter, what that means is there's a smaller spread between, for example, a 3-year, a 1-year and a 10-year instrument. And in our economy, this yield curve, although it's kind of a hypothetical thing, although you can chart a yield curve, it's constantly moving up or down. Now, what you're probably going to see over the next 2 or 3 years is you're going to see this yield curve become steeper. Because for the last several years, we've had some really looking yield curves, weird looking yield curves. We've actually been through what's called an inverted yield curve, which means that short-term rates at some point in time were paying more than longer-term rates. That's a very, very strange thing to see, but you do see it occasionally. So that's what we mean by yield curve risk. And then we've got price risk. And the first bullet point here, this is what you've all learned in all of your finance classes, the negative relationship between interest rates and bond prices. So if rates go up, bond prices go down. But there's also some other types of price risk. So for example, since when interest rates go down, the value of a bank's mortgage servicing rights generally decrease also, because total cash flows from servicing fees decline as consumers refinance. So you got to think about this in terms of not just always interest related, although typically most of it is interest related, but there are some fee changes too. All right, so based on this, we're going to look at 2 different types here. I don't know what's going on with this, but there's supposed to be a blue circle around this too. I could just see the start of it. I don't know. The system's kind of messed up tonight. We're going to look at 2 different types of models. Okay, we're going to look at, first of all, earnings at risk. So this is the profitability of a bank. This is a short-term model, and it's called gap analysis. Then we're going to look at what's called capital at risk, or a long-term model, and we're going to look at something called duration analysis. These other 2 simulations, these are a little bit beyond the scope of this class. So these are effective. They're probably more up to date than the first 2 methods that we're going to look at. The problem is, if you don't understand the first 2 methods, these other 2 are extremely confusing. So that's why we're just going to focus on these 2. And it says here at the bottom that regulators suggest that banks use both types of models, so that's earnings at risk and capital at risk, to get a complete picture of interest rate risk exposure. This has kind of become a hot topic in banking over the last 4 or 5 years. And so you've got examiners coming in, taking a look at this. They're doing all this heavy-duty modeling, trying to determine what's going to happen to the bank's earnings, what's going to happen to the bank's value of its stock. And so that's what most of this is. Now, one thing, and again, we're not going to really go into this in this class, but these models, just like any model, have assumptions. And the models are basically as accurate as the assumptions. So if you go in there and you put a bunch of junk into that model to try to get the results that you're looking for, I mean, they're not going to be accurate. And then you have to go back and what's called back test the model, which is take a look at how accurate was your model compared to what actually occurred. And if you're not getting some pretty accurate results, the regulators are going to write you up, or they may actually step in, because it's pretty apparent you don't know what you're doing with it. So again, these are things that when I teach this and I teach this at LSU, is primarily where I teach this subject. We go into and we talk a lot about these 2 types of simulation models, because this is, in reality, it's probably more accurate, but it's, like I said, it's a lot more difficult to understand. All right, now this is going to be difficult enough to understand when you first look at it. Something called gap analysis. This is just some comments about gap analysis. This is the oldest of the interest rate risk assessment tools. A lot of banks use this. It's simple. There's nothing really complicated about it once you understand it. It's probably too simple, but again, a lot of banks still like it. It's good at assessing the mismatch risk, but not other sources of market risk. It's what's called a static earnings at risk model. And it assumes, and this is a big assumption, it assumes a parallel shift in the yield curve, which means all rates change by the same amount at the same time. And we know, you know from taking money in banking, that's not true. But it's a good starting point, and it's a good learning tool to understand asset liability management. So, based on this, now these are really important items for you to know, okay? First category, interest-sensitive assets. We also call these repriceable assets. Now, don't make this more complicated than it is. These are assets on the bank's balance sheet that can change interest rates within a certain amount of time. So it could be the next week, it could be the next month, it could be the next 3 months, it could be the next year, but these are assets whose interest rates can change. And so if you take a look at this, for example, short-term investments. If you invest some of your deposits as a bank into a 3-month treasury bill, well, you know in 3 months, the interest rate that you're earning on that T-bill can change because you're going to have to reinvest it. And if rates went up, you're going to earn more. If rates went down, you're going to earn less. Short-term loans. If you make a 30-day bridge loan to somebody building a house, and their house is not finished in 30 days, so you have to refinance that 30-day bridge loan, what rates could change in the next 30 days? So you could earn more or less interest than you were earning before. Variable rate loans. Most commercial loans are variable rate loans. They're tied to some type of index, and so they can change daily, they can change weekly, they can change monthly. It really depends on how the loan is written, but these loan rates can change every day. So you're trying to figure out how much should I pay on deposits, but you may have a lot of, millions and millions of dollars of commercial loans whose interest rates are changing daily. So you're trying to keep that price risk to a minimum. And then you've got other loans and investments about to mature. You could have made a fixed rate loan 20 years ago, and it's going to mature next week. It's going to mature tomorrow maybe. And you're going to have to then make another loan at a higher interest rate or a lower interest rate, because I can almost guarantee you it's not going to be at the same interest rate that you made the loan 20 years ago. Now, if we had 2 or 3 of these items happening, for example, if we had one short-term investment maturing in the next 30 days, we had a short-term loan maturing in a week, we had one variable rate loan maturing tomorrow, and maybe we had another loan that's going to mature tomorrow, we could handle that. We could just kind of do the calculations ourselves. We've got 4 items maturing at certain interest rates. The problem is, what if you've got 10,000 items maturing in the next week? And they were all made at different times. Some were made 20 years ago, some were made 30 days ago. They're going to be repricing. That's what we mean when the interest rate changes. And we have to try to make some sort of educated, I'll call it an educated guess, at what's going to happen to our profitability when these 10,000 items mature, and we've got to start paying new interest rates, or we've got to start charging on these. We're charging new interest rates. Now, it's the same way on the liability side. You've got interest-sensitive liabilities or repriceable liabilities, and again, these are typically deposit accounts that can change interest rates. Fed funds, they can change, they're short-term. Savings accounts, they can change on a daily basis. Time deposits about to mature. So if you made a CD 5 years ago, and that 5-year CD is maturing tomorrow, you're going to pay a different, if it matures and they try to keep it with your bank, you're going to pay a different interest rate than you did 5 years ago. It's probably going to be a higher rate than you did 5 years ago. And then you've got any other short-term borrowings or variable rate deposits. So again, if we had just a few of these changing, we could look at our 4 or 5 assets that are repricing. We could look at our 4 or 5 deposits that are repricing, and we could handle this. But if we've got, like I said, 10,000 assets repricing this week and 10,000 deposits repricing this week, it gets a little more complicated. Now, let me just stop here and ask if everybody's following this to this point. Making some sense? If it's not, that's okay. And I will go ahead and tell you this now. If you walk out of this class tonight and you sort of have the feeling of what did I get myself into, you're right where you're supposed to be. Okay? I've taught this a lot of times. I've seen students' faces as they walk out of this particular lecture, and it wasn't even the week before spring break, okay? And they look bad enough. So, again, if you walk out of here and you're kind of confused, that's okay. Okay, we'll straighten that out. But don't think, wow, you know, everybody else is getting this. I'm not understanding it, because it actually will get easier, I promise you. So before the next test, it will get a lot easier. You just have to sort of take a step back, look at it, spend some time thinking about it, what's happening, and it'll be fine. But I'm just kind of giving you that warning, just in case you sort of feel bad when you walk out of here tonight. Now, I'm not saying you will. I'm just saying you might. All right. Now, a couple of items that we're looking at. Now, we have to determine, based on these repriceable assets and liabilities, what's going to happen to the bank's net interest margin. And we took a look at that when we calculated ratios in Chapter 5 and Chapter 6. And this was the formula for net interest margin. It was interest income, so this is what your assets are bringing in for you, minus interest expense, this is what you're paying on your liabilities, typically your deposits, divided by the bank's earning assets. Now this says that occasionally some of these calculations you use total assets, but primarily we use earning assets. And we said an earning asset is any asset that earns the bank interest. So loans, investments, that type of thing. It's not, for example, the building, it's not the computers, it's not the land, it's any asset that earns the bank interest. And what we want to take a look at is, depending on how your bank is situated, is it an asset-sensitive bank, is it a liability-sensitive bank, what's going to happen to the net interest margin? Is it going to increase or is it going to decrease? Because that's a really important part of our profitability. Now, the net interest margin, which we just looked at, it's influenced by interest rates going up or down, changes in the spread between assets and liabilities, changes in the volume of interest-sensitive assets and liabilities, and changes in the mix of assets and liabilities. So again, you've got a lot of stuff happening here. You've got asset liability mixes changing, you've got the rates changing, you've got the spread between the two of them changing, and you're trying to figure out how is it going to affect our net interest margin or our interest-based profitability. Now, as we take a look at this, there are going to be 3 different measurements that we're going to use for our gap analysis. The first one is called the dollar interest sensitive gap. And these 3 are basically telling us the same thing. They're just telling us the same thing in a little bit different format. So the first one here, interest sensitive assets minus interest sensitive liabilities. So this is a dollar amount. If it's positive, the bank is asset sensitive. If it's negative, the bank is liability sensitive. And that's going to make a big difference when rates are increasing or decreasing. The second one, it's called the basic gap ratio or the relative interest sensitive gap. That is equal to interest sensitive assets minus interest-sensitive liabilities divided by earning assets. You're going to get the same thing, the same overall result. It's just we're just saying this a little bit differently. And then the last one is the interest sensitivity ratio, which is interest sensitive assets divided by interest sensitive liabilities. So if this is, well, I'll show you this on the next slide. But those are 3 measurements we're going to use. Now, once we, and you can choose all 3 of these, you can choose one. Typically, most of the time you'll see a couple of these on most banks' GAAP measurements. But this is important for you to know in terms of what's happening with the bank. So if a bank is asset sensitive, it's going to have a positive dollar interest sensitive GAAP. It's going to have a positive relative interest sensitive GAAP, and it's going to have an interest sensitivity ratio of greater than 1. We're going to get to that next, okay? That's a good question because the time frame is really important, okay? So that's what we're going to look at next. Okay, so asset-sensitive banks. And we can do, I mean, you can just pick one of these out. It's going to tell you the same thing. Now, if you're a liability-sensitive bank, you're going to have a negative dollar IS GAAP. You're going to have a negative relative IS GAAP, and you're going to have an interest sensitivity ratio of less than 1. Because again, it's going to make a big difference as to whether you're asset sensitive or liability sensitive. And you really don't want to leave this up to chance in terms of where you fall. You kind of want to take control of this and try to steer your bank in the direction you want it to go. So, based on that, this is what happens depending on if you're asset sensitive or liability sensitive. If you are an asset sensitive bank and interest rates go up, your net interest margin goes up. Essentially, that means if you're an asset sensitive bank and rates are going up, you're making more money. You're making more money and you're not doing anything different than you have done previously. You just happen to be asset sensitive when interest rates are increasing. If you're an asset sensitive bank and interest rates go down, then you're going to lose money. And again, you're not doing anything different. You're not working less. Your employees aren't less productive. It's just that you were gapped in the wrong position when interest rates started falling. So that is if you're an asset sensitive bank. If you're a liability sensitive bank, which means you have more liabilities repricing than assets, if interest rates go up, you're going to lose money. Your net interest margin is going to be squeezed. If interest rates are going down and you're liability sensitive, you're going to have an increased net interest margin, which means you're going to make more money. And again, you're not doing anything different than you were previously. It's just you were gapped correctly when rates started falling. So a lot of what we're talking about here is based on interest rate forecasts and the accuracy of interest rate forecasts. Now, we talked about already, we pretty much know what's going to happen for the next year, 2, 3, 4 years in terms of interest rates. They're going to be going up. So if you're a bank, how would you want to be asset sensitive or liability sensitive at this point, knowing what we know about what's going to happen to rates over the next 12 months, 24 months, or 36 months? You'd want to be asset sensitive. There would be no reason for you not to be asset sensitive going forward. Do you think there are banks out there that are not asset sensitive right now? Yeah, there are. Okay? And some of them are trying to correct that. I'll show you in a minute how you could do that. Some of them are just kind of hoping things don't change much. I mean, that's not really a viable strategy, but that's what they're doing. I think, I know interest rates are going to go up, but I hope they don't go up as much as they say they're going to go up. Okay, that's not really the way you should attack this as the president of a bank. And then you've got the cumulative gap. This is just a running total based on different time periods. And so we're going to go back to his question in just a minute. But what this does is it measures the aggregate interest rate risk over the entire period as opposed to each time bucket. So to do this, and I'll show you this in just a second, but basically what a bank wants to do, they can determine to them the appropriate time buckets that they want to measure what assets can mature or change in interest rates and what liabilities can mature. So they may have a 1 week time, over the next week, the week time bucket, how much in assets can change interest rates, how much in liabilities can change. They might have a 30-day time bucket, a 60-day time bucket, a 90-day time bucket, and they're going to have numbers there in terms of what can change. And that's going to basically be a function of their decision making in terms of what they want to do over the next month, 3 months, 6 months, 9 months, whatever the situation may be. You'll see this actually on the table that I'll pull up here. It's called a gap report. And that's what this is discussing. It's simply saying that banks are going to put these in the appropriate bucket. You're going to see some banks take this out to 2 years, 3 years, even 5 years or more. I mean, that's fine. They can do that. But really, trying to guess what's going to happen to interest rates up to 12 months into the future, that's about the best you can do. So if you see a 2-year time bucket or a 3-year time bucket, that's simply a guess under the best case scenario. Okay, so about 12 months is about all you can do with this. All right, so this is in your, I think it's in your book. It might not be, I don't know. But this is, I'll turn these back on quickly. I just want you to be able to see this. This is what a gap report looks like. So this particular bank decided to slot items in terms of 1 week, 8 to 30 days, 31 to 90 days, 91 to 360 days, and more than 1 year. And so what we've got here, again, let's just take a look at the 1 week time bucket. You can, well, if it wasn't cutting the side off, you could see, all right, not moving. You can see the assets that can change. So for example, we've got 750, these are in millions, so we've got $750 million in business loans whose interest rates can change in the next 7 days. We've got $500 million worth of real estate loans that can change in the next 7 days. We've got $100 million worth of consumer loans that can change in the next 7 days. If we total all of this up, we've got $1.7 billion in assets at our bank whose interest rates can change in the next 7 days. If we look at the liabilities, we've got checkable deposits, savings accounts, money market deposits. We've got $1.8 billion in liabilities whose interest rates that we're paying can change in the next 7 days. So what we're going to do here, we can calculate this several different ways. If we want to calculate the interest rate sensitive gap, we simply take the interest sensitive assets minus the interest sensitive liabilities. And so for the 1 week time bucket, this bank has a negative gap. Or we could say they're liability sensitive. So what this means to us is if, let's see, where are we here? Okay, it says the bank's net interest margin will be squeezed if, in this case, since we're negatively gapped, if rates go up over the next week, the bank's going to lose money. And again, this is, the important thing about this is it's not that you're or the bank is doing anything wrong. It's not like they made a bad loan. It's not like they had somebody embezzle from the bank. They're doing nothing different. It's just interest rates are changing. And if they don't have their balance sheet set up to take advantage of that interest rate change, in this case, they're going to lose $100 million. Well, it's going to be 100 million times whatever the rates are here. We'll take a look at that on a slide or two later. But they're going to lose a huge amount of profit for doing nothing different. Now, we can look at the 8 to 30-day category. We've got 310 in assets maturing. We've got 600 in liabilities. So now we're at a negative 290. And the cumulative gap is going to be the negative 290 plus the negative 100. So now we're negative 390. And we can just keep going. 31 to 90 days. You can see that our 31 to 90 day gap is getting better, but the cumulative gap is still growing. So this bank is out to 90 days, it's negatively gapped, and then things change. You'll notice the 91 to 360 day gap is now positive. The cumulative gap has gotten smaller. And here we've got a very large bucket gap, and the cumulative is 0. But you can see here at the bottom what's happening if interest rates change. Interest rates go up, interest rates go down. So this is kind of what a bank would look at if it looked at its gap report, and you've got the loan officers, the people from deposits, the investment people, and they're looking at this and they're trying to decide, okay, what do we want to do? Now, if you're in the 1 week bucket, there's not much you can do in 1 week. But if you're in the 1 month, 3 month, 6 month buckets, you can change the composition of your bank's balance sheet over the next 6 months. Now, you may have to pay for that. For example, some of you who work for banks in here, sometimes your banks run specials on either certificates of deposit or maybe some loan specials. So we might decide to run a 6 month certificate of deposit special where we're paying a higher interest rate on 6 month CDs, and that's going to bring in a ton of deposit money in terms of 6 month CDs into our bank. Well, that's not by accident. Okay, the bank isn't just doing this because they're thinking, you know what, our customers have been good to us. Why don't we reward them with a really good interest rate on 6 month CDs? They're not doing that. They're trying to change the composition of their balance sheet because they are currently out of position compared to what they think interest rates are going to do over the next 6 months or 1 year. So if you see these loan specials or these deposit specials, typically it's for asset liability management purposes. That's why they're doing this. They're trying to change what this is showing for those time periods. Now, this is kind of a basic asset liability management report or a gap report. You can see one here. This is, it's a little bit easier to follow, a little bit simpler. You can see that, for example, in the 1 month time bucket, this bank has 5,300 in interest-sensitive assets. It has 8,400 in interest-sensitive liabilities. And so you can see the three measures that we have here. We've got the interest-sensitive gap, so it's negatively gapped. The interest sensitivity ratio is less than 1. And so if you're this bank, over the next 30 days, you want interest rates to go down. If interest rates go down, you're liability sensitive, you're going to make more money. If interest rates go up, you're going to lose money. It's as simple as that. The 1 to 3 month category, 750 in interest sensitive assets, 2,100 in interest sensitive liabilities. So again, you're basically, you're still negatively gapped, and cumulatively, it's getting worse for you. But it's getting worse if interest rates go up. If interest rates go down, again, you're better off. And then you can see 3 to 6 months and 6 to 12 months. Now, based on this, and I kind of answered this question for you, and I'll go back to the table in just a second. But some questions here. We've got ABC Bank. It's gapped at 30 days, so we could take a look at that. And again, that's what these red circles are showing. So it's negatively gapped at 30 days. What's going to happen if interest rates rise in the next 30 days? The bank's going to lose money. Its net interest margin is going to be squeezed, and it's going to make less interest income. And what's going to happen if rates fall in the next 30 days? What's happening is, and again, let me try to explain this. In the next 30 days, if rates go down, you've got $8,400 worth of liabilities that you're now going to be paying lower interest rates on. Remember, you're the bank. You're paying these interest rates. So you've got this amount that you're going to be paying lower rates on. You've got this amount that you're going to also have to lower the rates because interest rates are going down. But since you can lower more deposit rates than loan rates, you're paying less interest out to customers, which means you're going to make a higher net interest margin because rates are going down. If rates were going up in this time bucket, the opposite happens. You've got this much repricing in assets that you're going to be raising because interest rates are going up. You've got this much that you're going to be repricing in terms of deposits, so you're going to be paying higher interest rates on $8,400 worth of deposits versus earning higher interest rates on $5,300 worth of loans, which means you're going to make less interest income. And that's what we talk about when we say you're out of position or you're not in a position to take advantage of a rate change. All right, so and there are the solutions to that. All right, so how are we to this point? Everybody good? Why don't we take I'm going to get you out of here early tonight, but why don't we take just a 5-minute break, stand up, don't leave, okay? I know it's tempting. Stand up just for 5 minutes, then we'll jump back into this, and we'll get this knocked out and get you out of here. Those of you who are still awake, stand up. And we haven't fun yet. Does this make any sense? All right, so now this is, again, I think most of you probably are understanding this for the most part, but I wanted to show you quantitatively, what's happening with the bank's balance sheet and its net interest margin if it finds itself in the wrong position. So, is it helping, is it hurting, whatever. So we've got a bank here. We've got our original title here, XYZ Bank. You can see it has 500 rate-sensitive assets, 350 of fixed rate assets, 150 of non-paying assets. This is going to be a building, a computer system, whatever else. Now, this is what it's earning on these assets. It's earning 4% on the ones that are going to change. It's earning 6% on the fixed rate. This is liability, so these are deposits. It has 600 in rate-sensitive liabilities, 220 in fixed-rate liabilities, 100 in non-earning or non-paying, and then it's got 80 in stockholders' equity. So you'll notice both sides of the balance sheet, and it's a very simple balance sheet, but both sides. And this is what they're paying on these deposits. They're paying 2% on the 600 worth of rate sensitive and 3% on the 220 versus a fixed rate. Now, we can do these very simple calculations to determine what's happening with this bank in terms of its net interest income, and its net interest margin. So we're going to take the 500 multiplied by the 4%, 0.04, plus 350 times the 6%. So we are making 41, and this could be millions of dollars if you want it to be. So we're making 41 million in interest income on our asset. Paying 600 times 2% plus the 220 times 3%, we're paying 18.6 million in interest on our deposit accounts. The net interest income, or the spread, is going to be the 41 minus the 18.6, which is 22.4. Our gap is we are negatively gapped. So we're simply taking the 500 minus the 600. We're negatively gapped 100. So we're liability sensitive. And our net interest margin is going to be the net interest income divided by earning assets. So if we take the 2240, which is here, divided by our earning assets, which are going to be these two, the 500 plus the 350, which is 850, we have a net interest margin of 2.64%. So that's how we would calculate any of these numbers, and that's our starting point. Okay, now, based on this, what happens if, so there's our key numbers. What happens if we have a 1% increase in interest rate? So just 100 basis points. Well, you'll notice, again, take a look at this. This went from 4 to 5. This went from 2 to 3. Our fixed rates aren't going to change. Our yield goes to 46. Our cost of funds goes to 24.60. And our spread is now 21.40. We're still negatively gapped, but our net interest margin goes to, because we're negatively gapped, remember the net interest margin previously was 2.64%. Now, since we're negatively gapped and interest rates are going up, we are losing money. We've gone from 2.64 to 2.52%. And if you had a 2% increase in rates, you would see, again, for this particular bank, things just getting worse. And it's all because of this negative number. Now, if rates were going down, you would see this getting larger. Because this is what we're trying to do. We're trying to maximize our net interest margin. But again, this shows you numerically what's happening when we simply say if your negatively gapped and rates go up, your net interest margin is going to go down. This is showing you this happening. Okay? Now, based on this, and this is what we just showed you, but this is the formula for it, the change in net interest income is equal to the cumulative gap times the change in interest rates. And so, for example, if rates went up 1%, the change in net interest income is going to be the cumulative gap, which on our example was a negative 100, times 1%, which is going to be a $1 decrease. And if rates go up 2%, the change in net interest income is going to be a negative $2 change. So if we go back and take a look at this, you can see that here. This is our starting point. Net interest income was $22.40. Rates went up by 1%. Net interest income went down $1 to $21.40. And when rates went up 2%, net interest income went down by $2 to $20.40. So as rates keep going up, we keep losing money. And that's what our formula here is telling us. Okay, so based on this, so this is just your basic everyday gap analysis. What we can, and this is what we just talked about, so I'm going to skip past this. But this will show you what's happening to this net interest income in terms of dollars. All right. Now, these are some approaches if you're trying to, for example, reduce a bank's asset sensitivity, increase its asset sensitivity, reduce liability sensitivity, or increase liability sensitivity. And again, most of these make sense. For example, if you want to reduce a bank's asset sensitivity, you can buy longer term securities, you can lengthen the maturities of your loans, or you can move from floating rate loans to term loans. What we're trying to do here is we're trying to change the composition of our balance sheet. And that goes back to what I mentioned earlier, where banks a lot of times run specials, or they might hit a certain loan category really hard or a certain deposit category really hard. They're trying to change that composition. Now, I like this too. For all of these, you can simply do nothing and hope rates don't change, or they change in the desired direction that's going to help your bank the most. That's probably not what I would recommend, but it was in your book. It's been in several books, actually, so I wanted to put it there just to give you that option. But if you're this banker, you're going to have a stressful life, okay? Waiting on things to change in your direction, that's probably not going to happen. Okay, so these are some approaches, and again, this is just kind of a summary of this. You know, this is if you expect rates to change, go up or go down. Where do you want to be? If rates are going up, you want to be positively gapped. And now, this is talking about what's called an aggressive management strategy. This is banks management. They're trying to put themselves in the position to make more money based on interest rates increasing or decreasing. So if you think rates are going up, which we know rates are going up over the next 12 months, you would want to be positively gapped. And if you're not, okay, you want to increase the amount of interest-sensitive assets or decrease the amount of interest-sensitive liabilities. Because the more positively gapped you're going to be, the more money your bank's going to make, and you're not doing anything differently. That's the great thing, or the really negative part about all of this, is it's not that you're more productive or less productive. It's not that you have better employees or worse employees. It's not that you're a smarter bank president or a not so smart bank president. You're letting interest rates changing either make more money for you or lose money for your bank. That's either the beauty of it, or that's the really bad part of it, depending on how you're situated. So, based on this, we could also choose, if we wanted to have a zero interest sensitive gap or try to be perfectly hedged. So basically what that means is your dollar interest sensitive gap is 0, your relative IS gap is 0, and your interest sensitivity ratio is 1.0. If you are perfectly hedged, it doesn't matter to you if rates go up. It doesn't matter to you if rates go down. Because your net interest income, your net interest margin is going to stay the same. But how easy do you think it is to be perfectly hedged? And have the same amount of assets repricing as the same amount of liabilities during each time bucket. It's hard, okay? Really difficult. You can use derivative securities to help hedge your positions, but it's still a tough thing to do. You get close, probably, but it's hard to be perfectly hedged. And if you're close, then again, like I said, the derivatives help. So what you're doing, this is kind of the definition of perfectly hedged. You're going to insulate your bank from damaging effects of fluctuating interest rates, up or down, on profits. In other words, you're going to hold fixed the bank's net interest margin, which is, it's easy to say on a PowerPoint slide. It's much more difficult to do in real life. Now, we've looked at a balance sheet, and the balance sheet that we looked at, we had assets changing, we had liabilities changing rates. But we were basically assuming they were changing rates at the same speed. And we talked several slides back about something called basis risk. Basis risk means that assets and assets and liabilities change at different speeds. And so we can use what's called a beta adjustment to give us a more realistic sense of how is our bank situated. So this couple of things here. It typically assumes a 100 basis point change in the market rate, or what we call the driver rate. We said earlier that rates on assets and liabilities don't change at the same speed, and we've discussed this already. When interest rates are going up, loans tend to reprice faster. When interest rates are going down, deposits tend to reprice faster. And we're going to weight these rate-sensitive assets and rate-sensitive liabilities based on the speed at which they change. And again, this is called a beta adjustment. So this is going to be the change in the rate, the specific instrument rate divided by the change in the market rate of interest. So what we can do here is we've got the same information. This was from the first big table that we looked at. This was the 0 to 1. Is this the first one or the second one? This is the second one. This is the second table we looked at. Originally, we had 5,300 in rate-sensitive assets. We had 8,400 in rate-sensitive liabilities. So our interest-sensitive gap was a negative 3,100. And that is at the 0 to 1 month time bucket. But that was before we adjusted these. Now, notice here, the assets. If we use a number greater than 1, what we're doing is we're saying the larger the number, the faster these assets reprice. And the more they reprice by a higher rate. So, for example, Fed funds sold, we really don't have any, or our bank doesn't have any control over what we make on Fed funds sold. Okay? So we're going to leave them with a beta adjustment of 1. U.S. government securities, we can, we'll notice they're probably going to increase a little faster than deposits. So we're going to use a beta adjustment of 1.2. Municipal bonds, 1.1. Our loans, we're going to use a 1.4 beta adjustment because they're going to reprice fast. So what we're doing is we're taking these categories multiplied by the beta adjustment, and we're coming up with this entirely new set of numbers. So now our rate-sensitive assets go from 5,300 to 5,910. Notice our liabilities. We're using a beta adjustment of less than 1 on most of these. That's because they reprice slower. So in this case, for our now accounts, we've got a 0.8 beta, money market 0.85, savings accounts 0.75. We're readjusting these numbers, and so now instead of 8,400, it's come down to 7,635. What you'll notice is we're still negatively gapped, we're still liability sensitive, but this is a more realistic look at what would happen to our bank if rates increased over the next month. We wouldn't be negatively gapped 3,100, and more realistically, we would be negatively gapped 1,725. Which means we're still going to lose money, but we're not going to lose as much money as we would have here. And again, that's because of the repricing speed of the assets and the liabilities. Does that make sense, how we're adjusting those? Yes? Oh, okay, there's my looks. Okay, you guys haven't been showing those looks so far. Now I'm kind of getting the familiar facial expression. I feel better now. Okay, I think I am truly starting to confuse you. Things are going better for me. Okay, all right. So this is again what we're looking at here, and you'll notice the 2 key numbers down at the bottom. All right. So let me skip through this. You can see this on your handouts. These are, I'm going to jump through this pretty quick. I mean, this is pretty straightforward. Advantages of gap analysis. You don't have have to have a lot of sophisticated technology for this. It works pretty well if rates change by a small amount. If you have large rate changes, it's not very accurate. It's a near-term earnings measure. Believe it or not, it is relatively simple to develop and use, and it can provide clear, easily interpreted results. Okay, so those are the advantages. And disadvantages, well, we talked earlier about it assumes a parallel rate change. That doesn't happen very often. It generally only captures repricing risk. It doesn't measure the economic value of equity, or the EVE, and it may be ineffective for banks with more complex balance sheets. All right, so advantages and disadvantages. And we talked earlier about the two dimensions of interest rate risk. We said we've got earnings at risk, so this is, how much money can the bank lose or make, and this is how much in terms of stockholders' equity can the bank lose or increase. Now, the next part, this is pretty short actually, because what I did, I went through here and I cut out a lot of stuff because I'm assuming that you've talked about duration in your investments class. Am I right? Finance 333? With Dr. Durr, you probably talked about duration. Okay. And you might have talked about it in your ECO 305 class. So I'm kind of skipping through that. I just want to kind of hit the high points here. All right, so duration versus maturity. So we've got two different sets of cash flows here. With this particular investment, this is time period 0. This is today. This is 20 years from today. So you receive all of your money from this investment in 20 years. With this investment, you receive $900 after the first year, and you receive $100 after 20 years. Now, in terms of what's happening here, you'll notice the maturity of both of these investments is 20 years. They're both 20-year bond. We'll call them bonds, 20-year bonds. So the maturity does not account for the differences in the timing of the cash flows. Now, the next question is, what is the effective maturity of both of these? So for the first one, if we took the cash flowing in after 20 years divided by the total cash flowing in times 20, the effective maturity for the first investment is 20 years. For the second one, it's going to be the 900 first, and then the 100 19 years later. So the effective maturity of the second investment is only 2.9 years. This is a big difference. A 20-year investment, a 2.9-year investment. Because what we're measuring here is, when do you get your money back? How long does it take to recover your investment? So duration, although it's not exactly like this, it's pretty similar, okay? Because it uses a time-weighted average of the present value of the cash flows. Now, duration can get pretty complicated, okay? So again, we're not really going to jump into the numbers a lot, but I'm trying to get you just to understand the methodology behind duration and how it's used. All right, so here is a definition. Duration is a measure of the effective maturity of a security, or we'll call it a bond. In other words, the average time needed to recover the funds committed to an investment, which is what I said earlier. How long does it take you to recover your investment in a certain asset? It says duration offers a better measure of interest rate risk than maturity because it considers the timing and size of the cash flows. Duration measures how price sensitive a security is to a change in interest rates. And the greater the duration, the greater the price sensitivity. The shorter the duration, the lesser the price sensitivity. And we'll take a look at an example of this. So, just some basic duration concepts that you need to know. And again, I'm cutting out a ton of information about duration here, okay? So I'm just kind of hitting the high points. Duration measures the average maturity of a promised stream of future cash payments. If an instrument produces cash flows prior to maturity, then its duration will be less than its maturity. Now, you might want to write out beside this. An example of this is a coupon paying bond. So what this says is if this bond pays coupon or interest payments prior to maturity, its duration is going to be less than its maturity. So you may have a 10-year bond that has a 7-year duration. If there are no cash flows paid prior to maturity, for example, a zero coupon bond, or another name for that is a deep discount bond, then duration is going to equal that asset's maturity. And again, it makes sense. No cash flows occur before the asset matures. You get all your money, just like the first 20-year interest instrument that we looked at, where you got all $1,000 at the end of 20 years. That investment's duration would equal its maturity. And there's a negative relationship between bond values and interest rates, which again, that pops up all over the place when it comes to this. That's why you kind of wonder why we talk about that in every finance class. It's because it's a really important concept to know. Now, if you were in investments or if you were in some other class and you had to calculate duration, probably what you figured out pretty quickly is it's a real pain to calculate duration by hand. Even if you use a shortcut method, it's still time consuming. Well, this is something that actually is pretty nice to use. It's an online calculator, and it deals with Macaulay's duration, modified duration, and convexity. Now, some of this you don't really need to know, but if you plug the information in here, it's going to give you the duration of an asset, which is a lot faster than doing it by hand. How many of you had to do it by hand in an investments class? Now, you probably used a shortcut. You remember? Yes, no, you don't care. I know the answer to that question, okay? All right, so let's jump down here, okay? You can take a look at this later. The red's what's important here. When we're talking about duration and we're looking at this and we're going, okay, duration is the weighted average or the effective maturity of an asset. How does that help us? Well, it says that duration analysis can be used to stabilize or immunize the market value of a financial institution's net worth. So basically what we're trying to do, and I'm going to jump up one bullet point here, it says by equating the asset and liability durations. So if you're a bank, you have a loan portfolio with a certain duration. If you can equate the duration of your liabilities or your deposits, it doesn't matter to you whether interest rates increase or decrease because you're offsetting any negative effects of that rate change, up or down. But again, this is really, on paper, it sounds great. In real life, it's really tough to do. And it's tough to do for the main reason it's tough to do is because of what bank customers want. Bank customers want to borrow for long periods of time at a fixed rate, and bank customers want to deposit their money for short periods of time so that if rates change, they can then reinvest that money at a higher interest rate. That's where the problem comes in. Borrowing long-term, saving short-term. So as we take a look at some of the limitations here, which is what I discussed earlier, finding assets and liabilities with the same duration is almost impossible to do. Some assets and liabilities may have patterns of cash flows that are not well defined. Now, if you've got a car loan, you know the cash flows of a car loan. I mean, it's the loan payment each month. That's pretty straightforward. But you may have some type of sophisticated commercial loan where you've got certain payments coming in after a certain amount of time, and then you wait a few more months and you have other certain payments come in. So this would be, for example, if you've got a seasonal type business that's making loan payments, customer prepayments. If somebody pays off their mortgage early, they're screwing up your entire model. Okay? Customer defaulting. They stop paying their loans. That messes up your calculation. And convexity, we're not really going to talk about that a lot in here. If you look at the way we graph loans in class, what you're going to do is you're going to have a graph, and what you're going to say is, as interest rates go up, the price of a loan or the value of a loan goes down. Okay, so these are your rates, and this is your price. So as rates go up, you're going to notice the price for the loan going down. Now, what really happens is something that looks like this. This is actually what's happening to the value of a loan as interest rates go up. You've got this nice, you don't have a nice straight line, you've got this curve. And the difference between these two is what's called convexity. For this class, you don't have to know anything about this, okay, other than what it says here. But if you decide to get a MBA or if you decide to get a PhD in finance, then basically what you're talking about here is you're talking about this is the second derivative of the change of the price of this bond when interest rates change. So that's what this very fun topic of convexity is discussing. You should be happy with me just because I'm not going to talk about that tonight. Okay? That should make your whole night. All right. In a pretty fast, don't throw stuff, okay? Don't throw stuff. In a pretty fast discussion of asset liability management, I tried to make it as painless as possible. But what you're going to have to do at some point is you're going to have to go back, sit down, go over the slide, and try to make sense of what I talked to you about tonight. Is you're dreaming about the beach or you're dreaming about fishing or whatever it is. So there's no hurry, but you have to, again, if you have questions, come to me. I'll be happy to answer your questions. All right. Everybody have a good break. Be safe. Be careful. And I will see you back here in 2 weeks.